Hello, I am Moodita, and welcome back to Satisfactory. If you are new here, welcome. I was looking for a challenge for a new playthrough, and I decided on load balancing just about everything. So there are 0 factories with manifolds in this world. This is episode 34 of my load balance playthrough, and today I'm going to tackle the next space elevator part, magnetic field generators. I have all of the alternate recipes, so I'm going to utilize the solid steel ingot and the classic battery recipes. These are great alternate recipes that save on raw resources and power for the steel, and allow me to avoid dealing with fluids for the batteries. Compared to the last 2 projects, this is going to be fairly straightforward and simple. Because I've already ran into some traffic issues, I want to avoid using trains for the few resources that are not nearby. And with the amounts being low enough, I can use some drones for those logistics. I'm going to be using this spot and these nodes here. Let me try to explain what's going on here. So I know this is a bit much and a little bit zoomed out, so we'll zoom in to get a better picture. But this is basically the layout for the factory. So if we zoom into the top half, this is focused on making the batteries. So plastic and aluminum ingots are in gold. Those are already done, and I'll be bringing them in by drone. I just need to make some aluminum sheets using some of the copper that I'll be making, and then the rest of the copper will be used for wire. Some of that wire will be used in this classic battery step, and if we scroll down to the bottom half, we'll also need some copper sheets, some quick wire, coal to make the steel, iron for both the steel and to basically make modular frames. And then we'll bring that all together in 20 manufacturers to make our 20 magnetic field generators per minute. And here we are, back in the desert canyons. So here's our handy train station that we are not going to use. Well, spoiler alert, I do have to fix something, but we'll get to that later. So the 2 iron and copper nodes that are on the other side of the canyon that I haven't used yet are finally going to get used. And this is actually a bulk of what I need. I need these 2 nodes, and right around the corner is a Caterium node that I'm also going to be using. So I think it's right, that one right there. And besides these nodes, the only things I'm missing are 175 aluminum ingots, 200 plastic, and 150 sulfur. Oh yeah, and some coal. Forgot about the coal. The coal is just kind of awkwardly far enough that I'm just going to create a long belt, but it's right over there, just behind the arch, I think. But the sulfur, plastic, and aluminum, I'll be using drones to bring those in. So let me get these towers built, and we'll go from there. Here we have our Caterium tower, so it's going to be real simple, just 2 floors. We just need some smelters on the bottom floor and then constructors to make quick wire on the top floor, and then I'm just going to build those over to the main tower. Which, instead of doing 3 separate towers, I decided to just merge them all into one and make one giant tower that merged into the cliffside here. So on the bottom floors I have quite a bit less floor space, as it's kind of at the bottom, and since it slopes that way, as we go higher and higher, I gain a little bit more floor space until I have a ton of space up here and on the roof, which we are going to use this time instead of just for a power tower. Seems fitting to put a bunch of drones up here. Although I say up there, and unfortunately I just counted out the amount of floors that I have and I needed. So I'm sure I could probably figure out ways to squeeze in a lot more machines on each of these floors, but I just don't really want to. I'd much rather just give myself the empty space. Since we're at the end of the game and it's this and 2 more factories, I don't think I'm hurting for space in the world. So we're going to do 2 floors of smelters. And actually, now that I'm looking at everything, I think we're actually going to end up doing 3 floors of smelters. I think we'll just do copper on one, and then we'll do, instead of having to cut up the groups and stuff, we're just going to do big, nice, long lines of 25 smelters for each of the iron parts that I need to do. Then we're going to work our way up with some constructors, and then eventually we're going to use some assemblers, and this just isn't quite enough floors. I think I need 2 or 3 more. So let me get back to work, and I'll show you what I did. Alright, so let's get this tower built. Because it feels weird not to build anything in the video, but I am going to skip a lot of it just to try to keep this video a little bit shorter. Some of them have been a bit long, which I know some of you don't mind, and I really appreciate that. Alright, so I needed a minimum of 6 2/3 constructors. Since I'm going to have to underclock them anyways, I might as well place 8 and make it a little bit easier for the load balancing, even though I could do 7, but this is much easier. And thankfully, this isn't going to be too crazy a number, so I need 400 quick wire, and we're going to do that with 8 machines. So just a nice easy 50 per. So I wanted them facing this direction because I'm going to merge these two together, since it's all going to fit on one belt. So this is going to be 200, that's going to be 200, which means each one of these is 100. Let's make sure those are marked too. Perfect. And the same thing on this side. I need a splitter right here. This will have 240 Caterium ingots headed in, so I just need a Mark II on both of these, and that's all the belt changes we need to make. And now I can make it so we'll just put this here. 240, so it's going to be Mark III. And now let's do our smelters down here. So I want the output to go this way to make belting up easier. Let's see, so that's pretty even. Oh, I was looking at the wrong numbers. Let me change this before I forget. So this is only going to be 80 ingots coming in. So this is just Mark II. And those can be Mark I. Alright, so as far as this goes, 80 divided by 6. So this gives me 13.33. But, show you a little trick. I can actually get one more digit. Whether that makes a difference in the long run, I don't actually know, but it makes me feel better. Mainly because I can get this to be exactly 40. So I need an output of 80. We're going to use 6 machines. Divide that by the default rate of 15. And then multiply it by 100. And I get one more digit. And now this is 40 even. So that makes me happy. We're just going to copy and paste this. Alright, so these can both be Mark I, since that'll only be 40 on each of those. As far as plugging it in, we're going to have 240 ingots, which means that'll be 120, 120, and, oh, yep, we're just going to actually flip this one around. So flip that around, put that there. And then we can place our hole there. Mark III, lift into the splitter. And then from here, I don't think it's going to quite line up. Nope. Close enough. Oh, but nope, it doesn't quite line up. Oh, that's off. That's why. Alright, let's see. Is this close enough? And of course it's not. Well, in that case, we're just gonna make it look interesting. Let's see, so if we do... I've made worse things. Alright, so there we go. So that is the Caterium. So 240 ingots will end up spitting out 400 quick wire, and then I'll just create a bus to send that over to the main factory. And let me show you what I did over here. Alright, let's start down here at the bottom. So we've got one miner overclocked to 740. The other one is overclocked to 750. This one is overclocked to a really convenient 528 and a third. And that's all coming up to this floor where we have 18 smelters, all ever so slightly underclocked, but thankfully all of this fits on one belt, so it's really not too bad. It's got to go to a couple places, so we're just going to have to do some load balancing with that. But on to the next floor, we're going to be using the next 2 floors for iron smelting. The reason I overclocked the miners to 740 and 750 instead of both to exactly half is this allows me to have much more round and easy to work with numbers to do the load balancing. One of these rows, everything will be clocked to 100%, the other one will have ever so slight underclocking. So moving on to the next floor, we've got all of our foundries that are going to be doing the solid steel ingots. Since I needed 890 of iron and coal, it wasn't all going to fit in one system anyways, so the easiest way I could think of to split it up was to put a row of 18, and then a group of 5 would clean up the remainder. The next floor, we're going to use up all of those steel ingots and create beams and steel pipes. So for the beams, I'm just using a whole bunch of the 5 constructor blueprints, because I needed 20 of them. And then I only needed 5 constructors for all of the steel pipes. Here are the 10 constructors I need for the iron rods, and then I was able to squeeze the cast screws and iron plates all onto the same floor. So here's the 9 constructors for the screws, and then I'm just using 12 constructors to make the 225 iron plates that I need. The next floor has our modular frames and the reinforced iron plates. So the screws and the iron plates are going to be coming up here, and then the finished product will actually be being sent over to here and combining with the iron rods that we're also making from the floor below. So I needed 12.5 machines, so I figured the easiest way to do it would be to just use 15 and underclock them. And on the next floor, we've got the versatile frameworks. I needed 10 assemblers for that, so we've just got 2 sets of the 5 assembler blueprint. And I'm also making copper sheets and wire. I just needed 10 machines and 8 machines for those, all clocked to 100%, so nice and easy. And we move on to the electromagnetic control rods. I've also got aluminum sheets, wire, and the classic battery. So like I said, the floors just kept getting bigger, so I was able to squeeze in quite a few more machines on these higher floors, which is convenient. And to make the electromagnetic control rods, I need both AI limiters and stators. So the way I have these set up is the outputs are going to be facing this way so that I can just have those come straight into the input for the control rods for both of these. The aluminum sheets only needed 6 assemblers, they'll just be slightly underclocked. 10 constructors to make the wire that I need for the classic batteries. And the rest of the products that I need for the classic batteries, I think are all coming in by drone. And that's the reason I'm actually kind of skipping through a lot of the building of this. I'd like to focus on the drones and the logistics for that, and some of the fun load balancing, instead of making this super long building tons of machines. But before we get to all that, here's the top floor. So it's got 20 manufacturers, so I had to kind of cram them right next to each other, which I don't normally do. I like to give them a little bit more space. But to fit them all on one floor easily with 10 on each side, this was the easiest thing I could come up with. Now that I finally have the correct height of this tower, I can build some stuff up here on top. So since I really like to get the logistics part done early so I can work out any of those issues while I'm still building the rest of the factory, I'm going to create 1 or 2 blueprints to help speed this along, and I'll be right back. Alright, let me place down a blueprint designer. Really should have placed some foundations to make that easier, but this will be quick. And here we go. So this is what I came up with. So I'm going to place this and a slightly different variation. So the difference between the two is one is going to be already set up for imports, the other one exports. So we've got a little door here, and we've got enough space to where I didn't have to worry about any clipping. So it's just 2 normal walls split by 2 1-meter wall. So in some cases I won't need it, but I figured it would just be easier to set this up with most of the things that I would need if I was going to load balance right out of the drone port like I am for the trains. So we've got the merger going into the storage container, using Mark 5 for this piece, but only Mark 4 for this. Honestly, I can't think of anything that I'm going to be transporting from drones that would need a Mark 4, so I could probably have this lower. But for now, this is a good combo. And then I have the freedom to do any of my load balancing in here, and then I can either slap down a wall hole, or if this is on top of a roof, then maybe I just use a floor hole and send it to where it needs to go. So, and then I also just brought the power straight down through the machine so that you can't really see it. So I didn't have to have a whole bunch of wires on the roof. I can kind of hide them through the floors. So the other version is just ever so slightly different. With the export one, we've got the floor hole, conveyor lift, and everything set up. Just slightly move it over to the side to accommodate for the different port. So now, let me show you what it looks like on top of the roof. So I've got a total of 5 drone ports, so let's go through them. This one is going to do my aluminum ingots. This one's going to do sulfur. This one is going to be bringing in the batteries to supply all of the rest of them. This one's going to be doing plastic, and this one is going to be exporting the final product to the space elevator. So I've already got the load balancing set up and just a temporary sink setup. So after this, I'm going to be able to turn these on and we can test the throughput. So for the aluminum ingots, I need 175. And this is the chaos I came up with to do it. So what I did is I took a Mark III and then I split it 3 ways with the Mark II on each side. So we've got 90 on each one of these. So directly sent one of them back. So we started with 270, cycle back 90, so we're down to 180, but I need 175. So I need to send 5 back. So with this 90, I split it again in thirds. So we've got 30, 30, and 30. So this 30 goes into another splitter, and we're going to split it 3 more times. So 10, 10, and 10. And with this 10, we're going to split that in half. So there's our 5 that we needed to send back. And then basically everything else gets grouped up into mergers. And then for now, I'm just going to have it go out the side and into that sink. But most likely, these are just going to go through the floor. Alright, let's take a look at sulfur. So sulfur, thankfully, super easy. So we've got 270 on a Mark III. We're going to cycle back the 120 from the Mark II. And that just leaves me with the 150 I need. Gotta love when it's nice and easy. So as far as the batteries go, I did load balance them, although I know it doesn't really make a difference. They're going into a splitter. Half of it is going to go to the 2 drone ports on that side, the other half go to that side. And then for both of them, those go into this splitter. And so there's half and there's half. In total, I think these 4 drone ports are going to use maybe 10 to 12 batteries per minute. So the large majority of the time, those belts are just going to be stopped. And that's okay. I would much rather not try to figure out the exact load balancing needed for batteries and just not have to worry about them ever stopping. So with plastic, I need 200. So we took a Mark III belt, put it into a smart splitter this time. For this one, I set it for priority left and right with overflow going through the center. So we cycle back a Mark I belt, so that's 60 right away. We have another 60 going into here. From there, we're going to split it 3 ways, so 20, 20, and 20. This 20 is going to get split in half again, send 10 back, and the other 10 is going to merge back up with everything else. So we immediately sent back 60, and then we cycled back 10. And that'll give us our 200. So those 3 products, once I get those turned on, will just come to this awesome sink for now, just so I can make sure I only need 1 drone. And the funny thing is I got all of this ready, and I forgot one major detail, and that's the drone port on the other end that I still have to set up. Yeah, just a minor detail. Let me take care of that real quick. Back in the blue crater. It's been a while. And it occurred to me that I probably still had some extra plastic that I never ended up using. And this, if we take a look at the map, I think is a little bit closer. having the drone go from here to there, then going from here to there. Just by a little bit. Honestly, it wouldn't have mattered if I needed to pick it up from here, but since this was a tiny bit closer, and I had the extra 200 plastic, might as well just do it. So I slapped down my exporting blueprint, and we've just got that belted from there, so all I'm going to have to do is connect this belt, and it'll start sending 200 over to the drone port. Pretty simple, since all these machines output 60. We've got 60, 120, 180, and then if I split the 60 into thirds, I've got 20, and that gives me my 200. So this is already set up to send any this way overflow to the sink, so I just need to connect that belt and we're good to go. But let me show you the other two drone ports. Alright, and here we are back at the aluminum factory. Well, the main one anyways. So we needed a little bit of aluminum, not too much. We've got the exporting drone port here. And this silliness is what I came up with. So all I'm gonna have to do is switch the smart splitter to this direction instead of sending it that way. And this will load balance out my 175, leaving 375 left on this line. Alright, so to split off the 175, using a Mark V to start with a nice long stretch, because there's clearly gaps on this belt, and so we don't want those gaps to show up on our Mark III here, which is what we really need to work with. And so that's how I ensure making this is a full 270 that I'm working with. So with that, I've got it split three ways, so we're going 90, 90, and 90. This 90 is going into a splitter, splitting it three more ways, so 30, 30, and 30. This 30 is getting split three more times, so 10, 10, and 10. This 10 is going into this splitter, splitting in half, so we've got 5 and 5. So we have that initial 90 and then a 5 going back into the splitter. So since we're working with 270, we taking back 95, putting that in the sink, and that leaves me with 175 headed into the drone port. So it's just being merged up here, and then we're just going, already have a hole, cool. Just going through the floor, and through the floor, and into the drone port. Nice and simple. So that's the aluminum, and let me show you the last one, which is the sulfur. Tucked away in the back corner of the swamp, we've got a pure sulfur node that I am only going to use a fraction of because I only need 150. But I think this was the closest node, and honestly there's still some leftover sulfur in the world, and I'm not going to need any of it for the last two elevator parts, so it's okay. This is just super simple. I'm just sending it straight into the drone port. So the nice thing with drone ports, they function similarly to truck stops in the fact that the ports don't pause during the loading and unloading animations, unlike trains do. So you technically don't need a buffer. I just like to use it more often than not. But in instances like this, I'm only sending 150 per minute. The drone port itself can hold twice as much as what one single drone can carry. So right now I'm willing to bet that I don't actually need to use a storage buffer. But if I have to, it's real easy to add one. So let me get these all up and running so I can test the throughput, and I'll show you what it looks like. Well, before I turn on those drone ports, I should probably take a look at my power grid. Well, shit. That's not supposed to look like that. So thankfully, this nuclear disaster could have been way worse. And the issue is, I'm not getting enough sulfur over there. And there's two things I need sulfur for. One is the recycling, which was my first big worry. That's one thing I really don't want to have an issue with. So thankfully, it's this sulfur that's having an issue. And every single one of these train stations is full. And it took a while, many hours, because I had a decent enough buffer, and the amount that it's not able to transfer isn't a whole lot. We're only short by a little bit. So it took quite a few hours for this problem to show up, and I could have sworn I tested all the throughput, but this one just wasn't good enough. So what we're gonna do is slap another band-aid down, because I don't really have any room to extend this train station, I'm just going to add a second train. It's not my favorite solution. So that's going to grab the sulfur. We're just going to have it go on the exact same loop as the other one. Scroll down through all of these. So we're at the sulfur at Nuketown, and then you want it to go to the uranium because that's the major thing that train station is doing. And that right there should fix our problem. Hopefully that doesn't create more problems down the line. Okay, fine. I lied. It wasn't the only problem. There was one tiny problem. I had forgotten that these back 12 refineries are all slightly underclocked in compared to all the other ones. So all of these are running at 100%, and so all of these water extractors are clocked to what I thought they should be. These ones, instead of needing 24 water, these ones only need 23.5. That 0.5 was making these 3 water extractors run at 97 or 98%, but every once in a while they'd be too full because these machines aren't quite using enough. So these ones are set to 96, but what I really need is all of these ones to be set to 94. As far as problems go, having slightly too much water so they're shutting off is probably best case scenario, to be honest. And now the power grid is back to normal and where it should be. Back at the factory, we got the drone ports on and everything is syncing. And the nice thing is we can come in here and take a look. So this is incoming transfer rate of 194, which is pretty close to the 200 we're looking for. Now the sulfur is actually slightly over. These haven't been running, I think, long enough to get completely accurate numbers, but we can see that we're pretty close. So as long as when the drones come back, their bays aren't completely full, meaning they have less than the 9 stacks, I'll know for sure these are good. Now the nice thing with drones is as long as it's a low enough number, like the biggest one we're transferring is 200 a minute, but that's actually kind of false because 200 a minute is only 1 stack, whereas the 150 takes up 1.5 stacks, same thing with the 175. So, and as I can see, it's dropping off 714. So the throughput on this one is good, which means there's no reason the sulfur won't be good because that should be an even shorter trip. So thankfully, I only need 1 drone for each of these. Now, if any of them weren't able to transfer quite enough, the nice thing what I could do is go to the opposite drone port, add a drone, and set it to come to here. And then I would basically have 2 drones going back and forth to the same 2 ports. And you only need to supply 1 end with batteries. Then if 2 drones aren't enough, then you have to start adding more drone ports, and that can get a little bit messy and start eating up a lot of batteries. But thankfully, that's not something I have to deal with this project. So I decided to give the factory a little color, since so many of my factories are either silver, gray, copper, or some form of yellow. Or I guess black. Decided to spice it up for the last couple factories. So I did go ahead and do all of the belt work because I wanted to speed things up a little bit. But let me go through some of the load balancing. So for the most part, a lot of it's going to be really simple. Just kind of belting it all up, and then in another spot, I load balance all of the ingots. For the coal, I have those on a bus coming from way over there. If we zoom in, we can see the other end of the bus. So that right there is where they're coming from, right through those arches. So even though I have the foundries set up, so one part is taking in, I believe, 720, and the other is taking in the other 280 or something like that, I didn't want to set up the initial belts like that. I thought it would look better if they were both exactly even. So the coal is coming in at a rate of 445 each. So this is the load balancing I did to get, oh, here we go. It's 170 going one way, 720 going the other way. But that's nothing too special. Let me show you the part that I'm honestly most excited about. So huge shout out to Gamer61K3. You pointed me down the right path, and your description was fantastic. I just could not for the life of me quite visualize it in my head at the time. And eventually I knew I was going to go back to it and figure it out. And I hadn't needed it since I came out with that video a few months ago. So again, thank you. That comment was hugely helpful. So in the past, my assumption was if I did a 5-way split like I do with a lot of my machines, we've got a merger going into the splitter. We split that in half. So for this example, it's Mark II and Mark II. And then this one is going to split it all 3 ways. Now this one is going to go into 2 smelters, but I need to split it all 3 ways for all of this to be as equal as these 3, right? So we take that third output and we cycle that back into that initial merger. So meaning this belt right here is Mark III because it needs to be able to handle what's the initial incoming amount plus what ends up being 1/5 will cycle back through this setup. Meaning I thought that there was a max throughput for this sort of a system and I'd never be able to input something as high as a full 780 belt because then this would require 780 plus 20% and it just wouldn't work. But thankfully, with that comment, I knew they were right. I just couldn't quite figure it out in my head. And thankfully, I went back and visited when I came to this because this initial amount for both floors is either 740 or 750, which I'm splitting it 5 ways because I've got 5 sets of 5 smelters. So this is the modified version of this setup to get around that issue of that middle belt. So the first step is we actually go into a splitter instead of that initial merger. So this splits the entire thing in half. So now we'll just work with the highest amount. We've got 750. Now we've got 375 on both of these lines. Both sides then go into a merger, and then they go into a splitter. So splitter there, splitter up here. So this splitter splits it the 3 ways like I do with this setup right here. This splitter sets it into 2, so these 2 sets of 5. And then instead of looping back to that initial merger that was right in the beginning, I'm sending it into a splitter. And then I'm going to send half of that into this merger. The other half is going to go into that merger. So it effectively does the exact same thing as this, except for I get around that limitation that I always thought I had. And I have to tell you, it works fantastic. So thanks again. Even if I do forget to reply, because I am forgetful at times, I really do read all of the comments and I appreciate all of it. So both floors have the exact same setup because the load balancing works out the same. The difference is what these are clocked to. So the second floor is clocked to 100%. The bottom floor is clocked to 98 2/3. So 29.6 instead of the 30. And then load balancing the foundries, pretty simple. So 720 ingots and coal get plugged into this. Since this floor right here, everything's clocked to 100%, I could just not include one of the smelters since they're outputting at 30. So instead of the 750, I just knock off one and belt up the rest of them, and I've got my 720. And then I showed the load balancing for the coal, so that was pretty simple. For the next step, what I needed was 1200 ingots for one process and only 135 for the other one. So the easiest way I could come up with was, since this was going to have to be on 2 belts anyways, half of these foundries would equal 540. So belt up half and half, and that meant I was shy 60 ingots on each one of those. This isn't a completely full Mark III belt, so I did the smart splitter trick. We send the priority to the right and left. We use a bit of the Mark II to make sure we can make up for any of the gaps on here. And then we just send the 60 on down over to a merger. And that's how we got our 2 600s, the overflow being what's left for the steel pipes. We already did the load balancing on the floor before for the steel beams and the pipes, so basically just bring those up and plug them in and then send them on to their next stage. Alright, moving on to the next floor. We've got the iron rods, cast screws, and iron plates. All of this is being put together to make modular frames. So the interesting thing about this, I found, they're all default recipes. So to make 25 modular frames, you need 600 iron ingots. And it actually breaks down pretty simply. From that initial 600, if you split it into quarters, you'll get 150, which is what you need for the iron rods. With that remaining 450, the breakdown is 3/4 will go to iron plates, 1/4 will go to cast screws, 337.5 and 112.5. Now, unfortunately, there was a little bit of load balancing to get to that 600. So at first, what I had to do, this is the floor where all the smelters are ever so slightly underclocked, meaning working with just a single smelter is really not ideal. But if I group 5 of them together, at least I get a whole number of 148. So it's still not really the most ideal number to work with, so we had to use the smart splitter trick. So I have it set up so the priority is to the left, center is the overflow. So with the priority, I have a nice long belt of Mark III to make up for any of the gaps, because this is only going to have 148 out of the 270 it could hold, so there's definitely going to be some gaps. So this will make up for it. But then we're going to limit it down to a Mark I belt. So since we have 60 to work with, then I split it into thirds, so 20, 20, and 20. These 20 get grouped back up together with the overflow from the original splitter. So we have everything minus 20 being sent into this splitter. And from here, our priority is to the left, overflow to the right. What this does is I'm using the same smart splitter trick. So it's going to be Mark III for these sections, but then limited down to Mark II. So we've got 120 plus that first 20 that we split off. So here is 140. Since the whole floor outputs 740, we're now down to 600. So from there, we can do that split that I was talking about. So it's pretty easy. Just split and splitter, split it again. Now that's 1/4 heading off to the iron rods. The rest of it gets merged up together. And then we do the same thing. We split it into quarters, leaving me with the 2 amounts that I need for the screws and the plates. So like I mentioned, all of the iron products all get sent to this floor, create the reinforced iron plates with the iron plates and the screws. Since I needed 1 extra machine, just had to underclock it ever so slightly. And then those with the iron rods are turning into our modular frames. The next floor, pretty simple. All of these machines were really easy to load balance since most of this is already included in the blueprint. Just had to plug it in, split it right there down the middle, but this is where all of our modular frames and the steel beams from below are going. And then we're making some copper sheets and wire. So this is where we're doing the load balancing for the copper. So plugging into here is that really weird 528 and a third that we're making. This is how we're splitting it off to the 3 different places it needs to go. So starting with the smart splitter, the priority is to the right, overflow to the left. So with that, we're just using the same split built trick. So this will make up for any of the gaps, and then we're just limiting it down to Mark II, because that's all I need for the wire. For the copper sheets here, we've got the remainder going over to here and into another smart splitter. Priority is to the left and center. So using the same trick, we're limiting it down to Mark II and Mark II. And the way this is working is this one is going into a splitter, and I wanted to split that into thirds. So I should have given myself just a tiny bit more space, but I made sure I placed the exact right belt. So splitting it into thirds, we've got 40, 40, and 40. And with basically 80 combining with this 120, I've got the 200 copper ingots I need for the sheets, leaving me with the remainder heading to the next floor. Once we get up to this floor, we need to do just a little bit more load balancing to finish off the rest of the copper. I misspoke. I said 3 and needed to go to 4 processes. So we have that going into a smart splitter again, with the priority going to the center. So we've got it limited down to Mark I, and then we're splitting that in half. So we've got 30 going to each side. The other priority is also going to the left, and we're limiting this down to a Mark II. So we've got 30 and 120. So 150 is what I need for the wire, leaving me with the random number of 58 and a third that I need for my aluminum sheets. As far as the rest of the floor goes, We've got the stators, which is real simple. We have the wire and the steel pipes coming from down below. On the other side of this, we've got the AI limiters, which need the copper sheets and the quick wire that we're making from that tower that's going to be coming right along that belt. The outputs of both of these sides are just meeting in the middle with these 5 assemblers, and that's the 20 electromagnetic control rods I need for the final product. So here in the back, the wire and the aluminum sheets are both being fed into these 4 manufacturers. These are using the classic battery, and I did need to underclock it. Each one is only going to produce 25 instead of the normal 30 because I need 100 even. The plastic and the sulfur are coming in from our drone ports. And that brings us to our very top floor. So the load balancing was really easy, and this is why I wanted to lay it out with 10 on each side, is then I could do a 5-way split like I've been doing for everything else pretty much. And then those would meet in the middle, and then each of those halves would meet in the very center. So everything is actually being brought up from the floor below, and I just snake it along the ceiling from wherever it needs to come from. So the batteries are obviously right here. We've got the control rods from right here, and then the versatile frameworks are coming from below. And then all of the final product just gets merged up together into the front, and then we send it along up and over into the drone port. And that concludes our quick factory tour before we turn it all on. Alright, normally this is where I would flip the switch, but I've actually already flipped it. So the reason I did it a little bit differently is I wanted to test the throughput for those drones, and the easiest way I could think of would be to just kind of set up the power instead of coming up with a really weird temporary setup and then having to turn it off and then switch them back on, and I just wanted to avoid any issues. So I have everything already connected to power. The only things that aren't are all of the miners. So the other thing I will have to do is run up there and delete some belts and connect a few for the drone ports to get everything flowing into the rest of the factory. But since there's no switch to flip, I'll just start the timer with this first connection and we'll watch everything come to life. So this one is going to connect the power for the coal. I'll run through and connect these 3 miners, and then there will be one last connection to get the quick wires started. Alright, so at this point, I think we've got, plenty of copper ingots in here. Means probably plenty of wire in here. Oh, it's almost full. This was a little bit late, but we're gonna go plug in the rest of everything for the batteries. There we go. Nothing's headed to the sink, so that should be it. There we go. The first magnetic field generators. So now we have a nice steady flow of 20 magnetic field generators a minute. That is mission complete. Well, almost. I think we should probably send these off to the space elevator first. Alright, home sweet home in the grassy fields. So, I finally finished a bit more of the drone ports here. So, finally finished this fourth one. Got everything loaded up, and it's going to be easily load balanced since we're making 20, which is the same that we were making for the assembly director systems. So the initial amount will just come into this merger and then go into a small storage container. We're going to just have a Mark 1 belt coming out of here, and then we're just going to use all three outputs. So 20, 20, and 20. We'll loop back 40 of it back into here. That's why we're using a Mark 2 belt on this one. The rest of it's just Mark 1 since it's all going to be 20 a minute. And then I'm using a smart splitter here so that the priority is headed off into the space elevator, but once that's finally full, we're going to hand it on over this way, and it will join up with all of our nice parade of assembly director systems and start syncing. So it's already got all the batteries it needs. We just need to set this destination. Of course, I didn't simplify this one. There we go. And it's already replenishing the batteries that it's used. We just gotta wait a couple minutes, and it'll be right back. And there we go, a nice steady flow of 20 magnetic field generators per minute headed right into our space elevator. So as we can see, this number is slowly ticking away, but it'll finish in no time, well before I'm finished with the next factory. But for this video, that is mission complete. 2 drone ports bringing in space elevator parts down, 2 to go. So the next video is going to be thermal propulsion rockets. So look forward to that, and thanks for watching.